These link sheets discuss how you can have multiple representations of a linear model, okay, or a straight line. So you can have a word problem, you can make a table, you can have the equation, you can have the graph. And this section is just answering questions. So that would be a graph, a table, the equation, and a word problem, all representing the same scenario. So that means that there are 4 different representations of the same thing. Okay, so on this one that you were already given, it says Mr. Gibbs was designing an egg drop catcher to protect an egg when it dropped from different heights. He decided the best way to do this was to plot the area size appropriate to catch the egg based on how high the egg was dropped from. He found that if the egg is dropped at a height of 50 centimeters, that he needed 75 square centimeters to capture the egg safely. So at a height of 50 centimeters, so here's our 50, that makes this our height in centimeters, and it's telling us that he needed 75 square centimeters. That means the area, right? How big the catcher needed to be. So this, the size of, if I could adjust the size, we're pretending for a second, if I could adjust this based on how high up the egg is. So here's my egg, and the size of the yellow changes depending on how far away the egg is from the egg catcher. Okay? If the egg is completely on the table, then the size of the egg catcher, we don't need an egg catcher. It's already on the table. When I put it down and I let go, it's not going to crack, right? But as soon as I start lifting up the egg, it's saying that the size of my egg catcher, the area of it, needs to change. Okay? So, they give us that number. Also, we just discussed if the egg was on the table, which would be a height of 0, what does the area of the egg catcher need to be? Also 0, right? So we just grab some more data right there. That's in our table now. Okay, he discovered that for every 10 centimeters increase in height, okay, as the egg moves away from the table, 10 centimeters, 10 centimeters, 10 centimeters, 10, etc., right, that you need an additional 75 square centimeters to be able to catch the egg safely, aka it's not going to crack. It says for every 10 centimeters increase in height, the area needed to increase by 15 centimeters squared. Complete the table and the link sheet. Should the slope be positive or negative? Okay, well, x is our height in centimeters, H-E-I-G-H-T, and the y is going to represent our area in centimeters squared. Now, the units here, don't let the fact that this is squared boggle you down. These are just units for area, okay? How much area the yellow is. So I could have the area that's this, I could have the area that's this. The centimeter squared is just a unit for the area. It's not telling us to actually square anything in our math. Also, it told us already that at a height of 50 centimeters, we need to have 75 centimeters squared for our area. It goes on to say that every time the height of the egg increases by 10 centimeters, the area needs to increase by 10 centimeters. So as a result of our x changing, our value of y is increasing. Since our value of y, which is our dependent variable, is increasing, then our slope needs to be positive. Okay, so we need to do a couple different things. We need to fill in numbers here. We need to figure out what the slope is. We need to figure out the y-intercept. Well, we know that the slope, m, is the change in y over the change in x. Now maybe initially you didn't put in this 0, 0. Maybe you only put in the 50, 75, and then you didn't have anything else to work on. Well, this does tell us that when the height increases by 10, okay, well wait a second, here's an increase of 10 from 40 to 50. When the height increases by 10 centimeters, as it does here, that the value of y, our dependent variable, is going to increase by 15. So this needs to be 15, right? And then therefore this would be 60. Okay, well, it says the change in y. We know the change in y. The problem told us that the change in y was going to be 15. That it increases 15 centimeters in area whenever the height increases by 10. Now, the thing is, this is a certain scenario, right? So our slope, which by 0.5, but the thing is, this is a scenario. So it's not just 1.5. 1.5 what? Right? We need to have some units here. So this is the change in y. The change in y is the area. So 1.5 centimeters squared for the area per, right? Now if I needed to have a number under here, since I simplified this, it would be 1, right? So it's per 1 centimeter of height. So the relationship that we were given was for an increase in height, which is our x, of 10 centimeters. The value of y, our dependent variable, this is our independent variable. Our dependent variable increases by 15. We simplify that, and then we need to also have units. So the slope increases 1.5 centimeters squared for the area per 1 centimeter of increased height. Now our y-intercept. Well, I know that the y-intercept is when the height is going to be equal to 0, right? Because we find the y-intercept when the value of x is equal to 0. So when the egg is 0 centimeters above the table, aka it's laying on the table, I don't need an egg catcher at all. Correct? So that means our y-intercept is 0 centimeters squared. I don't need an egg catcher. Write the explicit equation in slope-intercept or the point-slope form. Well, since I have the slope and intercept, I'll go with the slope-intercept form. So I need to have y equals mx plus b. I need to fill in values for m and for b. I'm going to have y equals m was 1.5, x, and the value of b was 0. So I don't really need to put anything there. That means I can figure out all the rest of my boxes now using this equation, using this explicit equation. Okay, so y equals 1.5 times 20, and y equals 1.5 times 40. That one should give us 60, right? So 1.5 times 20, 1.5 times 40. I better get 60, and I did. Okay, so now I have my equation, I have my story problem, and I have my table, right? Those are 3 of the 4 representations of the same scenario. Now I need to make a graph of it. I see that for my x values, I need to go, I don't have to go all the way up to 500. I can just count by 20s. I need to be consistent, right? I cannot use these numbers. Well, what I mean when I say that is I can't count and put a 20 here, and then a 40 here, and then a 50 as the next one, and then as an 80 as our next one. I can't use these numbers as my exact labels because the intervals aren't the same. Between 20 and 40, it's a difference of 20. Between 40 and 50, it's a difference of 10. Between 50 and 80, it's a difference of 30, right? These numbers, the difference has to be consistent. So what I'm going to do is I'm simply going to go ahead and call this my origin. Okay, so there's 0, 0. This would be 0 centimeters because it's the height, because that's my x value. And then I would have 0 centimeters squared because that's my area. So my x stands for height in centimeters, and my y is my area in centimeters squared. So I'm just going to go ahead and count by 5. So 5, I'm going to count that 10. Okay, so then I know that my y, since my x I went up to 100, my y has to be able to go up to 150. Let's see how many lines there are. 1, 18, 19, 20. 150 divided by 20. I'm going to go ahead and count these by tens. So I'm going to say this is 10, 20, 30, 40. Okay, so I know that I have 0, 0, right? If the egg is on the table, I don't need an egg catcher. And then I have 20, 30, 20, 30, and I have 40, 60, 40, 60. Now, if you don't have the same numbers as me, that's okay, right? As long as what you have in there represents a change of 1.5 centimeters squared per centimeter. Okay, all right, and then the graph, I'm just going to call this egg catcher. And then finally, or you could call it height versus area. Of egg catcher. Alright, so then in these problems right here, it says use the explicit equation that you wrote. So the equation that we wrote was y equals 1.5x. To be able to answer the following questions. On the quiz and any assessment where it asks you to make predictions, that's what the majority of these questions are doing, asking for predictions, you must start with the explicit equation. So it says, if the egg is to be dropped from a height of 785 centimeters, this is the height. Well, back in our table, we said that height was x and area was y. So they're giving us a number for x. How big is the area? So they're asking us to find y. So you literally need to start with the explicit equation. Substitute the values in that they're giving you. Make your calculations and don't forget to put units. So 1.5 times 785. 1,175 and 5/10 centimeters squared. Mr. Gintz ends up making a catcher, which is 1,269 centimeters squared. This is the area. They're giving us y. How high was the egg dropped from? They're asking for x. They ask us to find x. So starting with the explicit equation, y equals 1.5x. This time they give us an area. Now we solve for x. (1,269) divided by 1.5 is 846, and don't forget units.